My name is Nelson, and I'm a researcher in sustainable energy systems at KTH in the Department of Energy Technology. In this film, I'll give my advice on what to think about when planning an investment in solar cells. The film is framed for multifamily houses, specifically bostadsrättsföreningar, or BRFs, but much of it can also apply to companies who rent out multifamily houses and to villas. The advice applies to most areas of Sweden where people are living, so basically from Sundsvall and south. In Norrland, the conditions are somewhat unique, so there might be additional or slightly different design decisions up there. I'm also going to use the term solar cells throughout the video to match the Swedish word Solceller, but in English they're usually called photovoltaics, or PV for short. In my own BRF in Stockholm, we installed solar cells in 2020, and I recently made a follow-up analysis on the technical and economic performance. If you're interested to learn about our experience with solar, you can watch those films at the links in the description below. We'll also provide links to some of my reports on solar energy and to Energimyndighetens Solcellerportalen, which has a lot of great advice. In these films, I am relying solely on my experience as a researcher of solar energy systems. I don't work in the solar industry, and these films are not sponsored. My main interest is to help people separate hype from reality and give an honest impression of sustainable building energy technologies. We're going to cover a number of topics in this film, and we divided it into chapters, so feel free to jump ahead if you want to get to a specific topic. In this film, we're going to answer the following questions. Should we consider solar cells? Which roof orientation do I need? What obstacles should I look for? Is my roof physically capable? Do I have the right energy demand? How do I find an installer? What maintenance is needed after installation? Is it worth waiting for new technology? Is solar cell manufacturing bad for the environment? And should I be adding batteries to my solar system? Should we consider solar cells? Well, solar cells are incredibly important for the energy transition, and rooftop installations are great because they don't require new land and they deliver energy directly where it's needed. They've also become so popular in recent years that they are oftentimes the first renovation idea that building owners consider. It's important to keep in mind that most energy used in Swedish buildings is heat. In older buildings, heat is about 2/3 of all the energy used. And in BRFs, most electricity is used in apartments, not in the property electricity. So your BRF might actually be buying 10 times more heat than electricity. In villas, heat is usually supplied with a heat pump running on electricity, so it's easier to use solar electricity to heat. But most multifamily houses use district heating and have a very low need for electricity. So while you're considering solar cells, look at your energy declaration or talk to an energy advisor to see what other efficiency measures you can take to reduce your heating demand. It's often very difficult to do a deep energy renovation because of the disturbances to residents and modifications to the building. So look for attic insulation or low energy windows. These are usually the easiest renovations to make. It might also be possible to recover heat from your outgoing ventilation, which accounts for about 20% of space heating demand. You should also check the age of your district heating substation. This is the heat exchanger that transfers energy from the heating network to your building. If your substation is filled with mineral deposits, it loses its effectiveness and you will need to buy more heat to overcome this loss. Heating efficiency renovations will have a greater impact on reducing greenhouse gas emissions and can have a comparable economic outcome to solar cells. Naturally, the ideal solution for each BRF is different, so talk with an energy advisor about your options, but it's worthwhile to consider heating efficiency renovations before or in conjunction with solar cells. The most sustainable energy is the energy we don't use. Roof orientation. Probably the first thing you'll be thinking about with solar cells is whether or not you have enough sunshine falling on your roof. The more south-facing your roof, the better, but in some cases you can go east or west. Any roof facing north should not be considered in any way. Most cities in Sweden have solar maps, or solkartor, which can help see how sunny your roof is. As a general rule, you'll want to target a roof that receives at least 1,000 kilowatt hours of solar energy per square meter per year, which you should be able to see on a solar map. If you're using one of the many online solar calculators that tell you how much electricity you can generate, you should aim for no less than 800 kilowatt hours of generation per kilowatt per year. Ideally, you should have about 900 kilowatt hours per kilowatt per year. Unfortunately, most of the calculators won't show you this number directly, but it's easy to calculate from what they do tell you. Take the total annual solar generation in kilowatt hours per year and divide it by the rated capacity of the solar cells, usually given in kilowatts. If you're having a hard time getting this number, make a note and be sure to bring it up to installers when you receive offers or discuss it with an energy advisor. Obstacles and shadows. Once you find a sunny roof, the next step is to look for obstacles that can interfere with the solar cells. Things like chimneys, ventilation pipes, or snow fences will break up your array of panels and could mean that there's less room for solar cells than you originally thought. There needs to be a good amount of spacing around objects, usually 50 to 80 centimeters depending on their height, to avoid shadows falling on the cells. When small shadows fall on just a few of the cells at a time, it might cause higher losses than you expect. For example, if I cover just one cell with my hand, which is about 2% of the total area, it can cause 1/3 of the panel to shut down. If those cells are not shut down, there's also a risk that they overheat, causing microcracks that reduce their efficiency and shorten their lifetime. It's also important to look for large trees or even flagpoles that can cast shadow on the cells. Some shading from trees can be acceptable, and you'll want to work with your suppliers or energy advisors to make sure it's not too much. You may also need to use special inverters or optimizers with that type of a system, which does come with additional cost. Roof structure. If you've found a sunny roof that's free from too many obstacles, you'll want to make sure that that roof is strong enough to hold the weight of a solar array. Each panel weighs about 20 kilograms or 10 kilograms per square meter. Some roofs may only be designed for snow loads and do not have enough of a safety margin for both solar cells and snow, so be sure to have an engineer check this before installation. You should also consider the age of your roof tiles, metal sheets, or asphalt. If it's only 10 or 15 years until they should be replaced, you might want to consider waiting to install solar so that you can place them over the new roof. Solar cells will last at least 30 years, and it adds a lot of cost to a roof renovation if you must remove and reinstall a solar system. Suitable building loads. So you found the perfect roof for solar, but does the building holding up that roof have enough electricity demand? Most BRFs have their own electricity meter for property electricity, and the residents have their own meters for their own apartments. Since the BRF is the one who will purchase and own the solar cells, it is only their demand that can make use of the solar electricity. It does not automatically go into the apartments if they have their own separate meters and their own separate electricity contracts. If your BRF uses district heating, like most do, then the property electricity demand might not be enough to justify a solar cell investment. Look for houses that have laundry rooms, as these tend to be the largest electricity consumers in a BRF. They also use electricity during the daytime, which matches well with solar energy. If the house with the laundry room is separate from the house with the best roof for solar, it is possible to connect them with a cable, but this option can be cost prohibitive. Another alternative is to install shared meters. This places the BRF and all the apartments together as one load, at least from the electricity network's viewpoint. This approach allows the solar electricity to be used directly in the apartments, which keeps much more of the generation within the BRF versus being sold to the network. Shared meters also reduce payments to the network company, and this savings is often worth as much as the increased solar consumption. Shared meters do come with some additional responsibility for the BRF, since they should now add electricity invoices to the monthly fee. But there are products and services available to help automate the process. You can also think that if there's a suitable place on the BRF's property, electric vehicle chargers are a great way to use more solar electricity directly. If your residents are interested in purchasing electric vehicles, and particularly if they use public transportation during the weekdays, then the cars can be charged during the daytime with extra solar generation. This keeps more of the solar energy within the BRF and has a much lower cost than the vehicle chargers on the streets. Finding an installer. There are many companies installing solar cells in Sweden, from small specialists to large international companies. Like any construction project, it's a good idea to get references and multiple quotations. Property managers like HSB and Riksbyggen can help provide a list of reputable installers in your area. You can also go to the website solcellskollen.se, which has listings for installers in your area with ratings and reviews from other owners. It's important to receive multiple offers to ensure you get a fair price. In the offer, you should see the brand and type of solar cell and inverter being recommended. This allows you to do your own investigations on the reputation of the manufacturers and the quality of these specific products. Most installers will also provide an estimate of the expected electricity generation and economic savings, and it's a good idea to review these offers with a third-party energy advisor. Every municipality has an energy advisor available at no cost, so it should be easy to find help. Once you've decided to install solar cells, you should think about the maintenance needed to ensure that they live on for decades. First things first, be sure to set up your production monitoring system straight away. Most inverters come with software that will track how much energy your solar cells produce. It's important to have this tracking and to review it regularly to ensure that your system is operating as expected. This is particularly important for a BRF, where the board has a duty to the economy of the community. The largest maintenance effort and cost comes from the need to replace the inverter, which happens between 10 to 15 years, depending on the model. Otherwise, the lack of moving parts really makes maintenance very low compared to most equipment. It's a good idea to check the modules once a year or maybe once every 2 years to make sure that the wires are still secure and no animals have damaged them. One of the largest risks of fire from solar cells is when the wires on the roof have come loose and are moving around in the wind, which wears away their insulation. So create a plan to check this regularly. Many people also wonder about the need to clean solar cells, usually thinking about snow. Here the answer is clear: not needed. There is so little production in the winter that the time and effort to remove snow just isn't worth it. During a sunny spell in March, it could be the case that more significant volumes of energy are lost from snow. But if you have to pay workers to take the snow away, it's likely that the costs are still more than the gains. During springtime, melts come quickly, so it's likely that the snow will clear itself away within a few days. Speaking of clearing snow, if you have sidewalks or port entries on the ground under the roof where the solar cells are installed, you need to think about installing extra tall snow fences. When snow comes off the panels, it usually slides off as one big sheet, so it can be very dangerous to have a large amount of snow falling directly onto a sidewalk. Even if it falls in the garden, safety precautions should be taken. One more common question is if the panels need to be washed in the summer from dust, pollen, or bird poo. The traditional wisdom was that in Swedish climate, there's enough rain to keep them clean. However, new research is finding that pine pollen is particularly sticky and that normal rains aren't enough to fully wash it away. Combine this with the fact that during May, the month when pine pollen is released, is also usually the driest and sometimes the sunniest month of the year. This means that the losses from pollen can be quite high. It's too early to say what should be done about it, but just know that if you have many pine trees nearby, that it could cause your system to produce 5 to 10% less energy than expected. Is it worth waiting for new technology? The quick answer is no. You can go for a solar cell investment today. In the last decades, we've seen a dramatic drop in the costs and rise in efficiencies for solar cells. So you might be wondering if there's anything new on the horizon worth waiting for. We're actually starting to reach the physical limits of a traditional solar cell. And the next generation of technology is starting to layer multiple types of cells on top of each other for more efficiency. This type of solar cell has existed for many decades, and the challenge companies face now is how to make it commercially viable, or in other words, make them at scale and reduce the cost. In the marketplace, however, this technology is unlikely to create a noticeable difference or jump in performance. Much of the efficiency gains we've seen in the past 10 years appear rapid, but the truth is that most of these gains have been driven by decreases in manufacturing costs that allow us to afford more efficient technologies that already existed. That's not to say that there haven't been any improvements in efficiency. There is continuous improvement, and that rate of improvement is actually increasing, but it's smooth or more or less predictable. One reason is that the new technologies are expensive when they arrive to market, so you tend to find the best economy with modern but not necessarily cutting-edge solar cells. So if you're ready for solar cells, then go for it. There's no need to wait for the next big thing. Isn't solar cell manufacturing bad for the environment? The vast majority of a solar panel is made of silicon, the second most abundant element on Earth. Most of this is in the glass covering the front and back of the panel, and the cells themselves are almost entirely made of silicon. Those two components make up 80% of the solar panel's mass. After that, there are nearly equal weights of polymer encapsulants around the cells and aluminum for the frame surrounding the panel. So that's about 99% of the solar panel's weight. The rest is mostly copper and silver for the wiring and very small amounts of borax, phosphorus, titanium, and oxygen. The panels are made in a lamination process. That's pretty low impact, but making the cells requires some specialist chemicals and quite a bit of energy. The amount of chemical processing is relatively small, so reputable manufacturers have a pretty easy time keeping them from leaking into the environment. If you want to check the environmental performance of a solar product you're considering, the Solar Scorecard is a nonprofit effort to score manufacturers and promote transparency in the industry. By far, the most energy-intensive part of making a solar panel is refining the silica into 99.9999999% pure silicon. About 70% of a silicon refining happens in China and is indeed mostly powered by coal. When you take into account all of the materials, the manufacturing, and the shipping, the solar electricity coming out of a solar cell in Sweden has about 1/3 the greenhouse gas emissions as the average electricity production in the Nordics. And from an energy standpoint, a solar system will produce at least 10 times as much energy over its lifetime as went into making it. Batteries. Many people are taking interest in batteries as part of their solar systems. In fact, nearly as many solar plus battery systems were installed in 2023 as all the solar systems in 2022. While they can help increase the amount of solar energy used directly in the building, it is very difficult to become 100% self-sufficient with solar cells and batteries. In the best case scenario, a battery will increase your solar self-sufficiency from around 30 to 60%. But it's important to keep in mind that the economic and environmental costs of achieving this are also quite high. Even with the 50% green tax deduction available today, the net economy of a battery is uncertain over its lifetime. So my suggestion is that only those with a keen interest in technology or a need for backup power should go for batteries. There are many electricity companies with contracts to purchase your extra solar production, so it's not necessary to have a battery with your solar cells. Plus, if you qualify as a microproducer, you can get a 60 euro tax reduction for each kilowatt hour you sell to the grid. This usually makes the price you sell solar electricity for greater than the cost of generating that electricity, so there's better economy in selling than storing. But here lies one of the uncertainties: future prices. Today, most electricity companies will offer the hourly Nord Pool spot price, which in the past few years has been above the cost of electricity coming from solar cells. However, we've also seen that prices become negative when it's very windy, now that we have a large fraction of wind energy in Sweden's energy system. The same thing can happen with solar, and in fact already does happen in a lot of places that already have a high amount of solar, like Australia, California, and Germany. So as we install more and more solar, both here in Sweden and in neighboring countries, it's more likely that the price for electricity will fall when everyone's systems are generating at the same time. If or when this starts to happen, then the value of a battery will increase. We can hope that the price of batteries continues to fall, especially as more and more used electric vehicle batteries become available for use in buildings. It could be the case that all of our solar systems will need batteries in the future, and it's okay to install a solar system today and add that battery later on. So if this is of interest to you, be sure to discuss it with your installer, because then you can prepare your system to have a battery plugged right in, making this addition later on much easier. I did my doctoral thesis at KTH between 2013 and 2019, and since then I've been working on two main research topics: developing hybrid solar, electric, and thermal panels for integration with heat pumps, and building a digital energy advisor that makes design recommendations and helps educate building owners about their sustainable energy renovation options. Is that the finish line?
Yeah.
Yeah. Very good. I wasn't sure if that one was going to be the 99999. They actually call it the 9 nines. It's 99 with 7 nines.
7 nines.
9 nines. The 9 nines of the earth. Oh,
Yeah.
thank you, Anders.
Thank you.